Hello again, this is Peter Lindemann for Tesla Chargers, and I just want to thank everybody for the fantastic support we've had in people interested in our product line, especially of the Solar Tracker 5 product line that John developed and we've been selling for about a little over a year now. And we get a lot of questions that come up repeatedly, and so this film is to try and cover as many of these issues as we can. And the primary question that we keep getting over and over is, which model do I need to use in the solar system that I'm designing, that I want to build? And the first thing is we're constantly asked to provide engineering services to help people design their systems and make all sorts of recommendations, and these are things that take an awful lot of time and effort, and we're just not equipped to provide that kind of service. So please don't ask us to design your system for you. There's a lot to know, and the idea that you don't understand how to design your system it's true, you don't know how to design your system, and or maybe you do, but if you don't, we're not the ones who can help you with that, because it's a fairly significant task. And so what we want to do today is we want to go through the process of showing you why there's an entire line of product here and not just one type of device that fits all needs. And for battery charging, hopefully you understand that almost every device that you have has its own battery charger. And that's because batteries need to be charged in a particular way, and that each battery has its own specific needs in relationship to the rate of charge and how much is expected to be given and how long that charge process is supposed to take, and so on. So these are the types of things that we're going to be talking about in relationship to the Tesla Solar Tracker 5 model line. And so the first thing is that we have basically 9 models, and this is for the lead acid type of battery for the most part, because lead acid batteries are still the most commonly used in a solar system. Okay, we have only 2 types of voltages for these. We offer them in 12 volt models and in 24 volt models. We don't offer any 48 volt models at this time or higher, and we're still looking at that possibility for much larger systems, but we're actually seeing in the field that people are getting better results by keeping their systems small. And if they need one system to run their refrigerators and one system to run their lights and one system to run their electronics, keeping the system small and isolated makes sure that in a real emergency, if your system goes down, you don't lose everything. You can always tap into one of the other systems if you need to. So we're still looking at the best ways of putting together solar systems, and if you haven't seen our free Solar Secrets, which is available on teslachargers.com, just click on that and download this 25-page book on our ideas about why solar has not worked so well down here on Earth when it's been working perfectly in outer space running satellites for over 40 years. So there's a reason for that, and we go through all that and talk about all the different things that are really kind of mistakes that people are making in the solar industry. So you can at least not make those mistakes if you want to find out all that stuff for free. Also, if you want to put together a big solar system and use batteries that may be being discarded by somebody else, then you'll want to understand the battery rejuvenation process. And definitely one of the best places to go with a medium-sized system for solar is the recycling of golf cart batteries. And we talk about that quite extensively in there, as far as that's a really important battery to look at again and be brought back. It's one of the easiest ones to rejuvenate, and you can bring back probably about 80% of the ones that are out there being recycled. And so we know people have put together a $20,000 battery bank for the cost of just trucking some batteries around in one of these big chargers. So anyway, you can look into all of those things as far as real ways of saving money on your solar system. But let me get to the process of how do you decide what system or which model of Solar Tracker 5 you may want for the type of system you're looking for. So again, what we have is we have 6 models that run on 12 volt. These are basically 12 volt systems for the batteries, and that number 12 right there in the model number is that it's for a 12 volt system. Okay. The first number is with the A after it. That means that's a 3 amp 12 volt solar charge controller. Okay, so the name is the specification. Okay, so this is a 10 amp 12 volt, 20 amp 12 volt, 40 amp 12 volt, 80 amp 12 volt, and 160 amp 12 volt. Okay, so that's our 12 volt line. The 24 volt line is the 40 A24, the 80 amp 24, and the 160 amp 24. So these are the ones that we are selling right now. Now, each of these 12 volt units is specifically designed for an input, a specific input from the solar panels. In other words, so these numbers here have to do with what we're calling the input to the solar tracker, but really this is the output of the solar panel. Okay, so these specifications are all on the specification sheets for each individual model, but we've kind of put them in a chart form here so that you can see them all at the same time. So this first input value, which is called VOC, this means the voltage when there is no load or open circuit. OC means open circuit. The voltage that the panel will produce in full sun when it's not being asked to do anything. And you can find that, that will be on a back panel listing on the panel, and you can also see that it's true if you just put a voltmeter across the panel when it's not connected to anything. So that's the number that we're looking for here. And panels are made in all kinds of different voltages and current ratings and different capabilities. And so what you're looking for, if you want to use one of these chargers, you're going to need to find panels that have these specifications. Don't look for things that are outside of these specifications because they either will not work or they will damage the unit. Okay? So the point is that it's very important if you buy one of these things that you also buy solar panels that are really compatible with the solar tracker. So what we're looking for is an open circuit voltage of 22 volts for the 12 volt units here, and we're looking for an open circuit voltage of 44 volts for the 24 volt units. Okay, so that is, so if it's 21, that's okay. If it's 23, that's okay. But 25 is too high. Okay, and 18 is too low. Okay, so this is the target number. Okay, this is the target number. The second value here is what's called volts at maximum power, VMP, and that's also usually listed on the back of the solar panel. And so the target we're looking for here is the voltage when the panel is asked to deliver current. Its voltage is going to drop down from this to this, and that's what we're looking for. In other words, this is the voltage it can supply its maximum current rating at. Okay? And so what we're looking for as the input to the solar tracker for the 12 volt units, we're looking for an input of 18.5 volts. That is, and it's listed as maximum power, but this is actually the true target. So if you're at 18, that's okay, but getting down to 17 and 16 and a half, it's too low. It won't, the machine won't work right. You won't get any power through it. But if you get up to 20, 21 here, that's too high and you'll overheat the unit. And because it'll be asking it to regulate too much power that it can't use. So this is the target value for this number on the panel. So 18.5 volts for the 12 volt series and 37 volts for the 24 volt series. Okay, so the third input value we're looking for is the current that the solar panel can produce at maximum power. So again, here these numbers you'll see are the same numbers as the model number of the device. Okay, so if you want a 40 amp 12 volt unit, you want 22 volts open circuit, 18.5 volts at max power, and you want the panel rating to be 40 amps in full sun. Okay, in other words, we don't want it to be able to produce 50 amps, okay, because that's going to trip the breaker here and shut the whole thing off. So this, again, this is a maximum input rating. So these are maximum input numbers, or these are targets. This is a maximum. There's actually a fuse on the input side of these charge controllers that will break the circuit if these numbers are exceeded by too very much. Okay?
And with those watt ratings or the amperage ratings, when you're starting to get up to the higher levels, most likely that's going to be made up of an array of multiple panels.
Yes, yes, you'll have, yeah, obviously these panels are getting bigger and bigger, and so you'll have multiple panels, okay? But if they're all coming down to a junction box and being brought into your controller area, obviously you're going to be using pretty big cable, you know, when you're starting to use this, and we'll talk about what kind of wire to use in just a second. Okay, so this gives you an idea of what you're looking for. In other words, the solar panels that you buy are very specific in relationship to whether or not they can be used with the Solar Tracker 5 models. Okay, and don't ask us if you can deviate from these numbers. Don't send us a model number of your solar panel and ask us if it's okay. You have to figure that out yourself. If you buy the thing and put it on something that doesn't have these specifications and it burns it out and it's really expensive, we're sorry about that. Okay, we wish you hadn't done that, but don't expect us to evaluate your equipment for you to and expect us to tell you what you're supposed to buy. That's your job. You can't afford us if we're telling you all that stuff, okay? We're just here to provide normal customer service and make sure that your order goes through properly, okay? We just can't offer you any kind of engineering, design services. Okay, so the output now, this output value is the output, again, of the Solar Tracker. Now we're talking about the output of the Solar Tracker 5 unit, okay? And what the Solar Tracker 5 is going to put out is what's going to be applied to the battery, okay? So the output from the solar panel is the input to the solar tracker, okay? The output of the solar tracker is going to be the input to the battery, okay, and so on. So, but we're talking here about the solar tracker. So these input values are what's coming out of the solar panel. These output values are what's going to be being applied to the battery. Okay, so let's look at these. The voltage at maximum power coming out of the solar trackers for a 12 volt unit, all of the 12 volt units are the same. It's going to be delivering 15.1 volts. Okay, doesn't matter what where the voltage on the battery is. Okay, the minimum voltage that these things can put out is 15.1 volts. So if you if this number drops to 15.1 volts, you can't get anything, you can't get any current through the unit. That's why this number has to be above this number, okay? This is going to be the minimum output number for the Solar Tracker 5 using John's proprietary linear amplifier circuitry, okay? So just realize that there's a specific relationship between this is the voltage at maximum power on the input, this is the voltage on the maximum power on the output, and you can see that this one has to be a couple of volts higher all the way across, okay? And make sure that that's there, because if this doesn't have this headroom here, then you're never going to get these amps through the thing, okay? So this number is really important. This must be your target for voltage at max power coming out of the panel. Okay, so the voltage at max power coming out of the solar tracker is 15.1 volts. The current is, again, the same as the rating. Okay, in other words, we want to pass all the current. We want to pass the same amount of current that's coming in as going out. Okay? And so this then gives you the basic layout of how many watts your system can move. Okay, so 15.1 volts times 3 amps is basically 45 watts. Okay, so what that means is that the maximum, WMP is watts at maximum power. Okay, and that's the output of the system. So if this solar tracker can handle 45 watts at maximum power, that means the biggest solar panel you can put on this is about a 45 watt panel that has these input specifications. Okay? So going down, each one of these has its own maximum power rating. So the S10A12 has a maximum input power rating from the solar panels at 150 watts, because that's as much as you're going to be able to get through it. If you can deliver 150 watts from this unit to the batteries, that's fantastic. But don't put this unit on a 200 or a 250 watt solar panel. It's just going to burn it out. Okay, it's going to offer it too much current under these specifications. Okay, so it's really important to understand. And these numbers are on the specification sheets for each of the units. And all we've done is we've taken all the specifications and put them all on this chart so you can see them all at the same time. Okay, and we've got this made up as a little chart like this, and we're going to put this on the website as well so that you can see all of them at the same time and get an idea more quickly than having to download each of the specification sheets. Okay, so basically these current at maximum output ratings are, again, the same as the name of the device. Okay, so this tells you a tremendous amount. The name of the model tells you an awful lot about it. And if you just understand what's going on here, then it's really not too complicated to understand. Okay, moving over this way, all of these units here are they're set up to have a maximum voltage output of 15.1 volts, and what that's designed to do is finish the chemistry on a lead-acid battery. Okay, that means that the batteries here are really 12.6 volts. They're called a 12-volt battery, but all of these models are for lead-acid batteries. Okay, really important for you to understand.
And we could probably mention that in the Solar Secrets, that free book, that there is the charts in there showing why those voltages are necessary. That kind of contradicts what a lot of people think you should charge a battery up to, and it's been in the books for 100 years. Right, exactly. And so it's all right there. Right.
So most solar systems are designed to maybe charge the battery to 14.6 or something like that, and then every once in a while push the battery up to 15.2 or 15.4 or something to equalize it. Okay. And all we're saying is, when you read this, what we're saying is that why not try and finish the chemistry every single time you possibly can? So that reduces how many times you actually have to equalize anything, and that way you can get actually more energy out of the system. So our regulators, our solar charge controllers are designed to top the battery voltage every single chance it has. If there's enough solar power coming in that day, it will take the battery to the top of its chemistry without having to change some setting or hurt the battery in any way by boiling the heck out of it trying to equalize the cells. So again, this is why this technology is here, because we want you to be able to put together a solar system that will run flawlessly, make your batteries last for 10 or 15 years, that you'll never have to equalize the batteries, and you won't need a backup generator. Now that's the kind of solar system we all want. So you can have that using this technology as long as you learn all of these methods. Okay? So this is for a 12-volt lead acid battery. And so people are always asking, well, how big should my battery bank be? For storage battery systems, battery capacity is listed in what's called ampere hours. In other words, how many amps can I have out of the battery for how many hours? Okay, so if we look at a unit like this, the 3A12, we know that in full sun this unit should be able to produce 3 amps. Okay, and let's say I've got maybe 6-7 hours of useful sun on a day up here in northern Washington and Idaho. You know, you're lucky to see the sun, much less get any out of, into a panel. But if you can get 6 hours of sunlight and get 3 amps out of it for each of those hours, then obviously 6 hours times 3 amps is 18 amp hours. Okay, so that's how many amp hours you might be able to get out of this charger on a given day, especially in the winter. Okay, in the summer you may be able to get more amp hours, but it's still going to be at the same rate of 3 amps. So we come over here, and so we look at the battery range that we may want to put this on. And so if we can charge at, say, somewhere between the rate that would take about 10 hours to charge it, and somewhere between the rate that it would take 20 hours to charge it. So this first number would be what's called the capacity 10-hour range, and this would be the capacity 20-hour range. So this would be the C20 rate of charge. And this actually produces a better charge. The slower you charge a battery, the better the chemistry works out. Okay? So what we're saying is that for the amp hour rating of a battery bank, the best way of charging it for maximum life, number of life cycles, and for the using the equipment the best it can, then we say that you should be between the 10 and 20 amp hour, or I mean the C10 and the C20 range in your battery bank. So the 3 amp unit would be good for battery banks between 30 and 60 amp hours. And you can go smaller and you can go bigger, but just realize that if you go smaller, it's going to charge faster. Faster charge means bigger particle deposition on the plates and less surface area in the end. So if you put a bigger battery on it and it's going to charge slower for the size of the battery, that's going to make the particle deposition smaller particles, more surface area, more amp hours. So if you have to charge fast in an emergency and everything like that, that's fine. But when you're planning your solar system, you definitely want to plan for the slowest feasible charge rate that you can get away with. So here are the amp hour range numbers that we recommend for this product line here. So the 10A12 is for 100 to 200 amp hour systems. And the golf cart battery is right at 225 amp hours. So that's a good battery for this, okay? And it's also a pretty good battery. It would be a good battery for this too. So just even 2 of the 6 volt, 225 amp hour golf cart batteries in series to make 12 volts, that gets you right into that range for either of these. The high end for the range here and the low end for the range on this unit here. Then we've got, so we just walk these things up. So basically the first number is just 10 times this, and the second number is 20 times this number, okay? So 400 to 800 amp hour, 800 to 1600, and 1600 to 3200 amp hour for the biggest chargers. So that gives you the idea of how to scale the system. The watt rating here is really the wattage output of the solar panel system that you want. The amp hour range is how big the batteries are supposed to be. And so the one thing we haven't talked about is how do we get the energy from the solar panel to the Solar Tracker 5, to the battery, and then back to your inverter, and then to run your house if that's what you want to do. So what we're saying is that for the small systems, we're saying 18 gauge wire is plenty. It's what probably comes with it. You can buy these actually with little cables and stuff, and I think they come with about 18 gauge wire, and that's plenty to pass 3 amps. Okay, but as the units get bigger and you're trying to move a lot more amps in these systems, you're going to need bigger and bigger wire. So yeah, for the 10 amp units, we're recommending a 12 gauge wire minimum. The 20 amp units, an 8 gauge wire minimum. 40 amp units, 6 gauge, 4 gauge, and number 2 gauge for the 160 amps. And you may even want to go down to 0 or what's called aught or double aught wire for some of these bigger systems, because this is a lot of amps. So and don't forget, you're trying to move this many amps across a relatively low voltage gradient. So again, you want to keep the distance between the solar panels and here as short as you possibly can. And the wire size coming out of the solar panels is probably not these big gauges. So you want to put together a little terminal box right next to or right behind the panels, and bring all the small wires from the panels into that terminal box, and then take these bigger wires and run it from those terminals to the Tesla Solar Tracker 5. So that would be the method for that. So the very first unit here is just a small unit, 3 amps. It's in a completely sealed case, and it doesn't have a fan. But every other model that we have does have an active fan, and it's designed to run off of the battery. Okay, these things, it looks like this has an input from the panel and an output to the battery, but actually this machine is looking at both the solar panel and the battery. And what you want to do is you always want to hook up the solar tracker to the battery first. Okay, and the reason for that is one, it's going to turn on all of the circuitry that is in here, and it's going to then say, I'm ready to take some power from here. Okay, but if you put this on first, before the circuit is turned on and ready to take the power, then when you connect to this, you may get a big surge that moves through the thing, and it's possible to damage the Solar Tracker 5. So when you're connecting the solar panel and the Solar Tracker 5 and the battery, always connect it so you connect the tracker to the battery first and then to the solar panel. And when you disconnect, you always disconnect the solar panel first and then disconnect the battery. And by doing it that way, the circuitry is always supported and protected. Okay, so that covers the 12 volt stuff. Of course, the 24 volt stuff is exactly the same, except it has just slightly different numbers. We're looking for a voltage, an open circuit voltage on the panels of around 44 volts. We're looking for a voltage under power of 37, and again, this is the target. And you could be, half a volt or a volt, one way or the other on this number, but really don't deviate from this number very much, okay? Here's the amperes that it can produce, and so these are the output numbers. And again, here's the wattage. So this unit at 24 volts would be good for 1,200 watts worth of solar panels set up in a 24 volt array. This one for 2,400 watts. This one for 4,800 watts. So these are getting into pretty big systems. These can produce quite a lot of power. Okay, again, this is for lead acid batteries set up in basic 24 volt systems. So that would be 4 6-volt batteries in series and so on, and then parallel out to get the amp hours. And here's the amp hour ratings again, and the wire gauge, and also these are all fan controlled. So yeah.
And with mentioning putting 6-volt batteries in series, like the Trojan golf cart batteries, for example, the T105s is pretty much what we recommend. Right. And in that Solar Secrets book, that talks about why using multiple 6-volt batteries versus 12-volt batteries that a lot of people want to use for simplicity.
Right.
But there is a reason, and that's all in Solar Secrets.
Right.
Why to go with 6 volts.
Right, and it's also why we recommend a battery like that, because one, it's something that can be easily replaced if it does go bad, and it's also it allows you to create a very interesting process which we call hardwiring equalization into the battery, and to find out more about that, get that free download. So what I want to do now is I want to just take a short break, and we're going to put some different information into this graph, and we'll be back with some of our new product line. Okay, so we've just recently announced a new product line at Tesla Chargers, and that involves specific chargers that are designed for the new lithium iron phosphate batteries. And the reason we had to put out a new product line for that is because of this number right here. The lead acid batteries all want to top at about 15.1 or 15.2 or so, but the new lithium iron phosphate batteries have really a maximum voltage in the 12 volt configuration. They have a maximum voltage of about 14.8, and it's really not good to push that specific battery chemistry above that number, 14.8. So we had to develop a unit that didn't try and push the finishing voltage quite so high, but still have a battery charger that was going to finish the chemistry at the end of the charge. So these are called the S3A. It's RV and Marine, but it's also got the lithium iron phosphate designation. And we also have a mid-range one for that battery chemistry. It's the 7.5 amp unit, and it's in the same kind of case as the 10 amp, but it has a fan and other things like that. But it's that's a great one too. So basically, we're still looking for the same kind of solar panel inputs, 22 open circuit, 18.5 max power for these current ratings, like the name says. But they're gonna top battery. In other words, the output from this unit is going to max out at 14.8. Okay, not 15.1. So at these voltages, or at these current ratings, same as those. And this is also a good voltage to top a sealed lead acid battery. In other words, the typical SLA, or what's called sealed lead acid. Something that you really don't want any kind of off-gassing at the top. Though we'll tell you point blank, don't put these types of batteries in a solar system because they can't give you, 10 and 15 years of service, okay? Because you just can't top them properly because they're sealed, and therefore if you produce any kind of off-gassing at the top of the charge, then their electrolyte would just dry out. So you can't top those batteries, that type of battery, at 15.1. They'll just dry out anyway. So you're kind of left. And so we definitely don't recommend using sealed lead-acid batteries in a solar system under any circumstances. But this is the proper voltage for topping the lithium iron phosphate battery. Don't mistaken that for a lithium ion battery, okay? Lithium ion, we don't have any chargers that will charge lithium ion batteries, okay? Don't, that's just, we figure it's a failed chemistry. It will be phased out as soon as people wake up. But this new lithium iron phosphate battery is one of the best batteries that's ever hit the market. And we're really very excited about what's happening.
And we recently put out a new video with Peter's explaining the lithium iron phosphate battery, showing the size comparisons and everything. That's on our YouTube channel, but it's also on the Solar Tracker 5 page within Tesla chargers, and we'd recommend everybody watch that, and that'll go over quite a bit on the lithium iron phosphates. And,
Right.
and there's also a wilderness model which is virtually identical to the S3A, but it's just a little bit smaller for backpacking and stuff.
Right. There's wilderness models, there's RV models, wilderness models that come with or without cables, and there's a number of variations on the small S3 units. And you can see all that at Tesla chargers when you get to the point of wanting to decide. So if you're backpacking and you want to take some solar capacity into the woods for, then you can get the little wilderness unit. But if you just want to sit in your backyard and get a Harbor Freight amorphous panel and charge batteries and have them as a backup, Aaron kept his refrigerators running during a power outage here we had this summer. So you don't need a lot of power for backup, but if you have none, then you could lose a couple $100 worth of food in your freezers, and then all of a sudden it didn't look so expensive to have a backup system. So anyway, so we have the two basic sizes, the 3 amp and the 7.5 amp in the lithium iron phosphate chargers, and again the small 3 amp unit does not have a fan. The 7.5 amp unit does. Again, the amp hour range for this charger is from 30 to 60, and Harbor Freight sells a 35 amp hour battery, which many people just use as a starting place. It's a great battery. It's a good. It's relatively small, but it is lead acid. It's heavy. But it's a good place to start. So you can get inexpensive places to start with these systems and have some backup capacity for your in a real emergency. So these are the specifications for the new line of lithium iron phosphate solar trackers, and we'll have a chart on Tesla chargers that show all this, something that you can download. And actually, if you want to just grab a shot of that right now, there's the complete chart that I've been talking about. And so if you want to just do a screen grab on that and print it yourself, that's easy too. So anyway, thank you for watching this and educating yourself a little bit more, and I'm sure that this information will be helpful to you as you start to design your own solar system, and whether you go with a really big system or whether you go with multiple small systems, take a look at Solar Secrets first, because there's some things in there that you really need to know and will help in your decision-making process. So once again, I'm Peter Lindemann, and this is Tesla Chargers. in a real emergency, if your system goes down, you don't lose everything. You can always tap into one of the other systems if you need to. So we're still looking at the best ways of putting together solar systems, and if you haven't seen our free solar secrets, which is available on teslachargers.com, just click on that and download this 25-page book on our ideas about why solar has not worked so well down here on Earth when it's been working perfectly in outer space running satellites for over 40 years. So there's a reason for that, and we go through all that and talk about all the different things that are really kind of mistakes that people are making in the solar industry. So you can at least not make those mistakes if you want to find out all that stuff for free. Also, if you want to put together a big solar system and use batteries that may be being discarded by somebody else, then you'll want to understand the battery rejuvenation process. And definitely one of the best places to go with a medium-sized system for solar is the recycling of golf cart batteries. And we talk about that quite extensively in there, as far as that's a really important battery to look at again and be brought back. It's one of the easiest ones to rejuvenate, and you can bring back probably about 80% of the ones that are out there being recycled. And so we know people have put together a $20,000 battery bank for the cost of just trucking some batteries around in one of these big chargers. So anyway, you can look into all of those things as far as real ways of saving money on your solar system. But let me get to the process of how do you decide what system or which model of Solar Tracker 5 you may want for the type of system you're looking for. So again, what we have is we have 6 models that run on 12 volt. These are basically 12 volt systems for the batteries, and then that number 12 right there in the model number is that it's for a 12 volt system. Okay, recommendations, and these are things that take an awful lot of time and effort, and we're just not equipped to provide that kind of service. So please don't ask us to design your system for you. There's a lot to know, and the idea that you don't understand how to design your system is it's true, you don't know how to design your system, and or maybe you do, but if you don't, we're not the ones who can help you with that, because it's a fairly significant task. And so what we want to do today is we want to go through the process of showing you why there's an entire line of product here and not just one type of device that fits all needs. And for battery charging, hopefully you understand that almost every device that you have has its own battery charger. And that's because batteries need to be charged in a particular way, and that each battery has its own specific needs in relationship to the rate of charge and how much is expected to be given and how long that charge process is supposed to take, and so on. So these are the types of things that we're going to be talking about in relationship to the Tesla Solar Tracker 5 model line. And so the first thing is that we have basically 9 models, and this is for the lead acid type of battery for the most part, because lead acid batteries are still the most commonly used in a solar system. Okay, we have only 2 types of voltages for these. We offer them in 12 volt models and in 24 volt models. We don't offer any 48 volt models at this time or higher. And we're still looking at that possibility for much, much larger systems, but we're actually seeing in the field that people are getting better results by keeping their systems small, and if they need one system to run their refrigerators and one system to run their lights and one system to run their electronics, keeping the system small and isolated makes sure that Hello again, this is Peter Lindemann for Tesla Chargers, and I just want to thank everybody for the fantastic support we've had in people interested in our product line, especially of the Solar Tracker 5 product line that John developed, and we've been selling for about a little over a year now. And we get a lot of questions that come up repeatedly, and so this film is to try and cover as many of these issues as we can. And the primary question that we keep getting over and over is, which model do I need to use in the solar system that I'm designing, that I want to build? And the first thing is we're constantly asked to, provide engineering services to help people design their systems and, make all sorts of